Okay, really quick, if you want practice or help on the extra credit, here it is. We have a rational function here, polynomial on top, polynomial on bottom. And let's first start by finding their asymptotes. And remember that a horizontal asymptote, really asks us just for the leading term. We just want to find the highest exponent top and bottom, and we want to use TIBO if we have to. And so let's just find the leading term. Top exponent up top is this x squared. But of course, there's a 3 on the outside. Let's distribute that in. So our leading term on the top is going to be 3x squared. And our leading term on the bottom is just x squared. And you remember that you reduce these, right? If they're the same, they're going to cancel out. And what we're left with is 3. So our horizontal asymptote is going to be at 3. And any horizontal line is defined by y equals. Horizontal asymptote at y equals 3. I've got the equation. The second one talks about vertical asymptotes. And vertical asymptotes, all we have to do is set the denominator equal to 0. So we take that bottom part and we just set that equal to 0. And we solve to see what will give us 0 only on the bottom. And what we get here is this is a difference of perfect squares. So x plus 3 and x minus 3, you can check that. That gives us -9, and then the two middle terms will cancel. And we're left with two answers. X equals -3 and x equals 3. The beautiful thing is that vertical asymptotes are defined by x equals. Those are vertical lines. And we have 2 of them. Great. And so now what we're going to eventually do is we're going to graph this function up above. All right, so we're going to take this and we're going to graph it. All right, what I'm going to do in the meantime is I'm going to erase all of this work because I want to just bring down part of it. And so let me clear my drawings. When we graph this function here, what's going to be super helpful is not only those asymptotes, but also the factored form of this equation. So I know that -5 and +2 get us to that -10. So that's a +2. And we had already factored this down into x plus 3 and x minus 3. This is our factored form. We had a horizontal asymptote at y equals 3 and 2 vertical asymptotes, one at -3 and one at +3. Interesting that we got a whole bunch of 3s here. So let's go down to the bottom. Ignore parts C and D for now, and let's keep this work to help us identify what this graph is going to look like. All right, let me draw some straight lines here for x and y axis. That'll be our x. This will be our y. And now let's graph our asymptotes. So I'll put our asymptotes in, I don't know, what's a good color? Let's make it kind of faint. 3. You're going to have like an asymptote there. I wish it was a dotted or dashed line. That might make it a little bit easier to kind of identify that it's an asymptote. But the very first thing I'm going to do is I'm going to set down those boundaries. We know that our graph is kind of bound by these asymptotes that we found before. And we really now just have to figure out where is it going on both sides of those asymptotes. So we know that it can't cross this vertical asymptote or this one. So as it gets close, it's either going to go all the way up or all the way down. It's only going to be one of those two things. So we've got to figure out which one. So how do we figure that out? To the left of -3 is the number -3.1. So this is going to be us with -3, and this is going to be to the left of it. I just chose a number really, really close to it. It could get closer if I needed to, but this is going to be close enough. And we're going to plug it into our function. We're going to actually plug it in. So anytime I see an x, I'm going to plug in a -3.1. Nope. And I know this is a lot of work here. I'm sorry. I wish I could have just had this all ready for you. Anytime I see a -3.1, we're going to put that in for x. Okay, now what we could do is we could do all of this work, plug this into a calculator, do it out by hand, order of operations, but we really don't care what number we get. It's either going to be a really big positive or a really kind of far down negative, because our graph is either going to be going up really high or down really low as it gets close to that line. So we really just have to know, is it a positive or negative number? And so with multiplication, you just really need to know the signs of each of these answers on the inside, kind of looking at which number has a bigger absolute value. And then we can multiply, and we know that with multiplying, 2 negatives become a positive. We get a positive over a positive. So that tells us that as we go towards -3 from the left direction, it's going to be going up. Let me put this in green. Green is good. And let me actually start with how I start. So to the left of -3, it's going to be going up. So let's work backwards from here. All right, so if I look at this graph, I can see that it's going up as it gets close to -3. Plugged in -3.1. To the right of -3, we got to plug in a different number. That different number would be to the right. Let's see, what's just to the right? That's going to be -2.9. And we go through the same exact process of plugging in -2.9 for all of these different areas. So -2.9 would go in here, 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 and here. I'm going to speed up this process, and I'm just going to tell you what we get. We get a +3, the -2.9 in there would be negative. The -2.9 would be there, would be negative, -2.9 there, negative, but here it would turn into a positive because -2.9 is actually less than 3. And so we get a positive over a negative, which is actually a negative infinity. So what does that mean? That means as we're going to the right of this line, we're going to be going down. So to the right of -3, I'm going to put a downward arrow, and I could just put part of my graph. I don't know if it's going to be going all the way up, if it's going to loop back down. I really now have to go look at these two things over here. So I got to go through my paces in the same kind of exercise where I plug in 2.9, which is going to be to the left of 3. And then I got to plug in 3.1, which is going to be to the right of 3. And I've got to go through that process. Now let me skip forward here. If I plug in 2.9, I'll get a positive number. And if I plug in 3.1, let's see, I can't even remember. It's going to be positive on bottom. It'll be negative on top. It'll be a negative number. So to the left of 3 at 2.9 is going to be going up. So let's just kind of connect these two sections, looking something like that. Sorry for my little weird scribble there. And to the right of 3, that's going to be going down. So we'll have that arrow pointing down, and we can just work backwards from there. And our graph looks something like that. So the process is pretty long, right? We had to find our asymptotes, which we found from up above. And then we had to find to the left and to the right the behavior around those asymptotes based on points that were very, very close to the left and to the right, to the left and to the right. We didn't care about the whole number. We just cared about the sign of the number. Okay, where was it going? Up or down? Okay. Take this information, transfer it, and now try that other one on your own to the best of your ability. Yes, I do want to see this type of evidence that shows me that you're going through the process. Don't be like me here. Okay, that doesn't really show me the process that I need to see that really locks in your understanding. Thanks.